we'll talk about what are multi-platform images. So how can we build them, and what is the actual need for building multi-platform images? Okay. So when we talk about multi-platform, so what is the meaning of multi-platform? So it is the platform, like it is for the CPU architecture and the operating system, right? The CPU architectures can be AMD architecture, x86 64 architecture, right? ARM architecture, right, guys? So there are multiple architectures. So imagine you created your Docker image in AMD 64. Okay. So will it work on ARM architecture, machines?
No.
It won't work because the architecture that you have used to build the image is different than, whatever architecture you are using to run that particular container image. Okay. So what are these multi-platform images then? So these are the images that are designed to run on multiple architectures. So which means if you create them on AMD 64, they can still run on ARM architectures. So how it is possible? Okay. So before understanding that, so let's see why, Docker has to, go for multi-platform images. Okay. So if you see, Apple recently moved to ARM architecture with their M1, M2 chips, right? Correct? So earlier they were using this AMD, now they are using ARM architecture. So will those Docker images that you created on AMD will work on Apple M1 MacBooks? They won't work. Okay. And another thing is, so AWS also launched their own set of processors called Graviton processors. So which are not based on usual AMD 64. Okay, they are based on ARM architecture. Okay, so these Graviton processors, easy to instance types offer much better performance than your regular EC2 instances. But the thing is, they are not based on normal AMD 64 architecture. They are based on ARM architecture. So which means if you have to consume these sort of instances, you should build the images using, you should build the images targeted to run on ARM architecture. Correct. Right, guys? So
Yes.
this is actually Raspberry Pi, the one which you're seeing in the middle. So this is a smallest computing engine. Okay, I think many of you might know about this. Okay, so it also runs Linux with a separate flavor known as Raspbian OS. Okay, it has various configurations like 4 GB RAM, 16 GB internal storage, and one core CPU. Okay, so it uses ARM CPUs. Okay, so I can't just zoom in and show you. Um, I can't see much. Okay. And see, these are Graviton processors, but these are based on ARM architecture. Okay. So that's the reason why, you need to go for building multi-platform images. And if you look at any image on the Docker Hub, okay, and if you click on tags and if you select any tag, you will see a lot of OS by architecture information here in the tag. Got it? Like Linux by 386, AMD 64, ARM v5, ARM v7 architecture, AMD. So there are a lot of you know architectures on which this BusyBox can run. So how can a single image can run on all the images? Okay, is it possible? So ideally, it is not a single image. Okay, so here Docker Hub is showing this as a single image. Okay, but if you look at each architecture, it has a different digest or the SHA value. Okay, so which means each of these images is separate, but Docker can just provide you that complete information under a single tag. Okay, so when I take this BusyBox image and let's say if I use Docker pull BusyBox on a Windows AMD 64, so what will happen is I'm going to download, I mean, Docker CLI is going to download only the AMD 64 version of this BusyBox. Okay. If I try to pull this on M1, Mac M1, then ARM version of this BusyBox will be pulled. Got it? So you will not have all the images for all the architectures on a single machine. Okay. It's not possible. You can download only one tag. Okay. I can only download latest tag for only one architecture. By default, it will be, your Docker will automatically detect the underlying architecture and it will download the appropriate version. Got it? Okay. So let's say if you want to pull a specific architecture image, so you can also use -- platform and you can set it to any of this information like Linux ARM64. I can just put it and the name of the image and appropriate tag. So you will pull the image, okay, for that particular architecture, even though you are on a different architecture. Okay. But always remember, if you're trying to pull this BusyBox latest for this architecture, it will be available in your local machine with this architecture. If you try to pull other architecture, it is going to replace the previous architecture image because you can have only one BusyBox image, available locally. Okay. So how do I, build multi-platform images? Okay. So if I just say I don't want to use, yeah, multi-platform, multi-architecture, both are same. Okay. So let's say I don't know the concept of building multiple architecture images. Okay. All I want is I want to build an image that runs on Apple M1. Okay. Let's consider a simple scenario. Okay. So if I take from and the base image like Python Alpine, okay. And if I try to run it on my, AMD 64 architecture, that is my local Windows machine. Okay. So let's not consider about this for now. Let's say this is a simple Docker file. So what will happen to this is, so when you're running on Windows AMD 64, but I'm interested in ARM 64, this won't work. Okay, the reason is the from instruction, which is trying to pull this Python. Okay, it will always pull the AMD 64 version on your local machine. So the image that you will be building will only work on AMD 64. Okay, but it can use -- platform, which is set to, let's say, Linux ARM 64. Okay, then this from instruction will try to pull the ARM 64, version of this Python Alpine 3.19. Then the image that you'll be building will only run on ARM 64. Okay, so the reason why I just use this R keyword is so that I can use it as the build arc and then set the architecture directly here. So in case if I have to build it for AMD 64 or ARM 64, I'll simply change the architecture through build arguments. Then I can build it. But again, as I said, you can build only one image and then you can, push it. Okay. So let's say for ARM 64, I'll call this as a test ARM 64 and then I will push it. Okay. So it is available in the Docker Hub. The next time I build AMD 64, and for my easy reference, so I'm just calling it as AMD 64 tag, and just for my understanding, guys. And then I pushed it. Okay. But the thing, what will happen if you do like this is you will see these images as two separate entries in your Docker Hub. Okay. So let's say if I, see any image in Docker Hub, let's go for Nginx. And if I just click on the tags, okay, you can see for this particular tag, you have OS by architecture, which will be which is supporting these many. Okay. But if I follow this approach, whatever I discussed, like building an image for a single architecture and pushing it, okay, and building it for other architecture and pushing it, you won't find that particular image, a single image, with multiple architectures like this. It is not the possible. Okay, you will see them as separate tags, like, the ARM 64 tag, AMD 64 tag as two separate images. Okay. even though those are multi-platform images, but the thing is you build them separately. Okay. So if someone wants to run that particular image on ARM, so they have to pull that image with that particular, let's say, test ARM like this. If someone wants to, run it on AMD 64, they need to use AMD something like this. Okay, they need to mention the tag. It's not like that they use test colon latest always, and their operating system, depending upon the operating system, Docker CLI will automatically select a appropriate tag. So it is never going to be the case. Okay, clear, guys? Understood?
Yes.
Okay, so let's say you don't want to follow this approach. So you just take a plain Docker file. Okay, but you can build it for a separate platform using hyphen hyphen platform again. Hyphen hyphen platform, you just select whatever platform that you wanted to target, and then you build it. Okay, so automatically this Docker from instruction will use this platform to pull the proper image. Okay, so either you go for this or you go for this, but always remember these are just to generate the platform images separately. Okay, so you will be storing them as separate tags. But my motto is to have all the images under a single tag with all the architectures. Okay, then anyone can pull this tag, the same tag, but depending upon their underlying operating system, a proper base image will be downloaded. Okay, still I do not have that here. Clear? And let's say you're running, AMD 64, okay, on Windows. And if you try to pull a Linux ARM 64 image like this, and if you try to run, you're going to get an error. The error says that there is a mismatch in the host platform and the image platform. Okay, it won't run. In some cases, you'll also get this error, exec format error. Because where you downloaded the image for a different platform, but you're running Docker on a different platform. Okay, so we understood basically how to create images for multiple architectures, but this is not how you store and distribute. Okay, so in a few minutes you'll understand why. Okay, so there are two ways that you can use Docker to build multi-architecture images. So one is the old method, which is not being used, using Docker manifest, and the other is through Docker Buildx. Okay, these are the two ways. Okay, uh, before understanding Docker manifest or Docker build kit, so let's understand how Docker is able to build multi-platform images. Okay, so if you see, if I simply set platform to a different value, okay, it is trying to build the image for that platform. Okay, even though I'm running on a different platform, but still I am able to generate those images. So how this is actually possible? Okay, so let's take the case of a simple, Docker installation. You can take my Docker installation. So I'm running x86 64 architecture on Windows. Okay, so this is my base setup. Okay, on Windows, basically Docker either requires Linux Kit, okay, or Windows subsystem for Linux to run Linux containers, because so on Windows you cannot directly run Windows Linux containers. So Docker takes the help of either Windows subsystem for Linux or Linux Kit to run your daemon and also to create containers. Okay, but here my architecture is x86 64 still. Okay, so I can only create the images targeting that architecture. Okay, or whatever architecture that Linux Kit is having. Okay, but what about creating the images for ARM v7, for ARM 64, or ARM v6? So these are the architectures that are not known to my machine, right? So how this Docker engine is building all those multi-platform images? So it is using QEMU, okay, also known as quick emulator. So what is the role of this emulator is, So this is again a virtualization software. It allows you to mimic or emulate various other architectures. Okay. So let's say I'm on x86, but still I can develop a software for ARM-based platforms and still test them on the same machine using QEMU. Okay, using this emulator. So basically, when you're trying to create a different architecture image, you're actually using QEMU to create such Docker images targeting various platforms. Got it? So that is one thing I wanted to show. Okay, so now we understood there are a couple of ways using which you can generate multi-platform images. One is Docker manifest and the other is Docker build. But by the way, what is Docker manifest? Okay, what is this manifest file? Okay, so in order to understand, so let me quickly show the difference between Docker image inspect and what is manifest inspect. So this is how you understand it. Okay, so let me first pull um, probably Ubuntu image. Okay, I'm just or you can take let me take BusyBox. It is much easier to download because it is much lighter. Okay, so now tell me when I'm doing Docker pull BusyBox, so which version of BusyBox is getting pulled?
Latest.
Yeah, that is the tag, but which platform image it is getting downloaded? So it is
86.
basically downloading Windows AMD 64. Okay, the same you can see when you try to inspect the image. Okay, let's see. So in the architecture, you will see it downloaded for Linux AMD 64. Okay, of course, my Docker is not running on Windows, it is running on Linux kit. Okay, it is AMD 64 Linux. Okay, so I can download a different version of the image. So using -- platform. Okay, so this time I'm trying to download Linux. Um, let's say V7, V4, or sorry, V5, V6, V7, or ARM64. So let me download for ARM64. So here this is going to replace the default image that you already have. So now when you inspect this image, you will see that it is changed to ARM64. Okay, clear, guys? Understood.
Yes.
Okay.
To try to create a container with this image, it will fail, right?
It will fail. Yes, it will fail. You try it, it will fail. Okay. So now the question is, so whenever you want me to try it, guys, I can try it. Anyways, we just downloaded ARM64. So let me start and also use --rm to remove it. Okay, it says, you can see the images platform doesn't match the host platform. Okay. So now the question is, so when I'm trying to pull BusyBox, okay, so Docker is trying to pull the AMD 64 version by default because that is the host architecture. Okay, so how how Docker know uh, you know which tag to pull? I mean, it is obviously mentioned it as latest. Okay, but how do Docker CLI knows or the daemon knows? So which appropriate image to pull, or what are the available architectures for this BusyBox? Okay, so for every Docker image, there is a manifest file that is maintained. Okay, so what is that manifest file is? So that manifest file is a simple JSON file that will have information about the image, like what all target architectures it is supporting, what is its size, what are its layers. Okay, so every information about that Docker image is available in the manifest. Okay, but Docker image inspect will only inspect the image which you just downloaded for your current architecture. But manifest will have entire information about the image, including its various architectures. So Docker manifest inspect, I'm going to just use the same BusyBox. Okay, it takes time because it has to pull the manifest file from the remote location again.
So the manifest file by defaultly it will create, or we need to capture it and push it to GitHub or something?
I'll tell you. So by default, it will be created for single platform images and it is always pushed. But multi-platform images, I'll tell you. Okay, so
Okay.
it takes a lot of time basically. Okay, so meanwhile, I can also show the one which I have. Okay, I think it has downloaded. Okay, so you can see Docker image inspect BusyBox. Um, see platform AMD 64 Linux. OS, ARM v5, ARM v6, okay, ARM v8, okay, some PPC, MIPS. Got it, right, guys? So this is how Docker daemon will know which version to pull. Okay, so you can see it has the information about the architecture, the SHA value, the size. Okay, everything is there. Clear? Okay. So, but if we try to build, using our old approach, like, you know, just changing the architecture or building the image, okay, for a platform and pushing it with a different tag, that is a different tag itself, which means if you try to check the manifest, it will always have um, you know, the information about a single architecture. Okay. So this manifest, so if your image supports multiple architecture, your manifest file should indicate it. Okay. So that's the main motto. Okay. So how do you create this manifest? First of all, uh, what you have to do is you have to create images for various architectures and then you have to push them. Okay. So for example, let me, you know, go to a different folder. Okay. So this has a Docker file, this Docker file. I did not mention any platform and nothing like that. Okay. So let me first build it. Let's say Docker build -t. I'll call it as something like, I have to tag it with my own name. Let's say multi-arch. Okay, that's the name of the image. And then let me, push it uh, for AMD 64. By default, it is AMD 64. So the platform, I don't have to write the platform value here, uh, but let's write it. Okay, AMD 64. So I'm building it for AMD 64. Okay. And then let's try to push it. Now let me try to build it for ARM. Okay, so this is where you change. Okay, ARM 64. That's the platform. And I'm also tagging it with so that it is easy to identify. Okay, remember, changing it in the tag will not create image for that particular architecture. You need to use -- platform.
This will pull the from Python Alpha and 3.19 for ARM, right?
Correct.
For
Yes,
building.
correct. Yeah. Okay. Now let me try to push this ARM version. Similarly, You can build for other architectures. So currently I'm not showing them. It all depends upon the requirements. So now let me go back to my Docker Hub. Okay. You can see this multi-arch. This is the multi-architecture. This is the name of the image. But if you see, the tags are pretty different. Okay. You have ARM64 tag, AMD64 tag. Okay. Now tell me, if I simply use this name, so will my Docker daemon appropriately select a tag and then download depending upon the host architecture? No, it is not yet possible. Okay, because if I click on any tag like ARM64 tag, see, it is only supporting ARM64. Got it? It is not like I select ARM64, but still it will download AMD64 if I'm running AMD. It is not yet possible. Okay. In fact, let's say if I click on this latest tag, okay, you can see this is different. So because I built it properly last time for multi-architectures, so let me, delete it. So currently we don't have any latest tag. And of course, pushing the latest tag using this previous approach, will not, it will not be a multi-architecture image. It will be still a different architecture image. Okay. So currently all the tags are, separated. Okay. So everyone is a separate image. Okay. Separate tag. They have their own manifest and all. So how do I create a multi-architecture images embedding AMD64, ARM64, and information about all the other images? Okay. Other architectures. Okay. So first I need to create this manifest file. Okay. So Docker manifest create, you can create, let's say I will use this same multi-architecture and I'll call it as something like V1. Okay. So what I'm trying to do is I'm trying to create my own manifest file, Docker manifest create, and I'll call it as this name, multi-architecture V1. Okay. So which means, your manifest will be available with this particular name. And to this manifest, I'm going to embed all the images and the proper tags. Okay. Like AMD64 manifest, ARM64 manifest. Okay. All gets embedded into this particular manifest. Okay. You can see the command. Okay. So let me try to create a manifest first. Okay. So remember, I'm not selecting multi-arc latest and all because I don't want to create confusion. Now what I have to do is I have to push this manifest. Okay, the one which you created, that is V1. Okay, it is pushed. Now what will happen is if I just go back to this multi-arc repository, okay, so you have V1 here. V1 is something like a tag here. Now if you click on this particular tag, right, it supports multiple architectures. See, AMD 64, ARM 64, which means if anyone uses this particular name, depending upon their underlying OS, an appropriate image will be downloaded. Got it? So I can go back to this repository, and if I click on these tags, you can see V1 is now pointing to two different architectures, but AMD 64 and all those things, right? They are, separate. Okay. Clear, guys? So let's say, I want to download that particular, pull that particular image. Okay. So if I run this command on AMD 64, it will download AMD 64. If I want to download the ARM 64, okay, on Windows machine, then I have to separately do this like this. Let's say I'm trying to pull ARM v7, but ARM v7 is not there, right? It is not supported as the architecture, right? Guys?
Yes,
Yes.
sir.
And also, by the way, once you create this manifest, you can actually inspect it. So if you inspect this manifest, you're going to find all the platforms that you have used to build it, like ARM64, AMD64. Now, what I'm trying to do is I'm trying to forcefully pull ARM v7 platform. Okay, see here, no matching manifest for Linux ARM v7 in the manifest list entries. So which means inside this image, first, when Docker tries to pull, it will first download the manifest, see whether that particular image is built for that particular architecture or not. If it is there, then only it is going to pull it. Otherwise, it is going to throw an error like this. Got it? Clear, guys?
Yes.
And also, let's say, I don't want to mention hyphen platform and all to pull a specific image. What you can do is you can click on, let's say, ARM64. You can click on that one. So here you'll have this, not here. Will it be here? No. Okay, if you just click on this particular SHA value, okay, you can see there is this digest that is coming, right? Okay, you can just copy it. And then how to use the digest is, so after this v1, okay, after this Docker image name, okay, you can just simply put that digest like this. Okay, so if I don't use this platform now, if I use this SHA value that is related to that platform, so Docker can, one second, it's not copied. Okay, you can also use the SHA value to pull a specific image. Okay, so by default, it is already there in my local machine. That's what it is saying. Image is already up to date.
The naming
Clear?
convention for this, the naming convention will be with SHA or without SHA? I mean, in
At
the
the rate SHA, with SHA.
okay.
You can see here.
Okay. Oh no, not here. I'm afraid just type Docker images in the local, the name in the local.
No, it is just an identifier.
Okay.
You will not see that SHAs and all in the Docker images.
Okay.
Okay. So that is an old method of creating multi-platform image using the manifest. Okay. So there is another method which is using Docker Buildx. Okay, so Buildx, as we already know, it's a CLI plugin. So that will talk to your builder and extend its functionalities. Okay, so in order to build multi-platform images with Docker Buildx, your default Docker driver doesn't support it. Okay, you need to use again Docker container driver. Okay, as we used it previously. Okay, you can see, with a simple command. Okay, so once you have the builder created, okay, with a simple command like docker buildx build -- push and the name of the builder. Okay, you can simply select -- platform and you can give multiple platforms separated by comma. Okay, and then tag it and push it in one go. Okay, clear? So it may not be clear. So let me just take an example. So which one we will take? We will take one which is easy to build and push. Okay. So let me go back to this repository, this folder. So this is some Golang. So here is your Docker file. Okay. So it is which Docker file we will use? We will use this multi-stage build Docker file. It can be any Docker file that you can take. Okay. So I'll take this multi-stage Docker file. I'll build it for multiple architectures using Docker Buildx. Since we already have that builder, right? So which is based on Docker container driver. Okay, because we just built it, right? Okay, but that is not the the default one. What I'll do is I'll use Docker Buildx to build multi-platform images. So Docker Buildx, build. I also want to push. Okay, so the name of the file is dockerfile.multistage, and I want to tag it with my username slash. I'll say go multi-arc latest. And so this is what you use to push a single platform image. Okay, Docker Buildx is going to detect the underlying stage and underlying architecture, and it is going to generate it. But here you can pass multiple architectures using hyphen platform. So I'll just build for ARM64, Linux AMD 64, so Linux ARM v7. Okay, ARM v6. So I can give any number of platforms here. Okay, and then Docker Buildx requires exactly one argument. Okay, I just have to put dot also to mention the context. It says, okay, so I'm missing one slash in the platform. Okay, it's Linux slash ARM64, Linux slash ARM v7. Okay. So it says, yeah, because it is using a default driver, right? I need to use which driver? I mean, which builder? The container builder, which we created previously. Getting it, guys?
Yes.
Okay, it says there is an issue with this distress base image. It says it is not found. So let me just go to distress images and take proper. Because we should also see whether all the base images that we are using, okay, support that platform or not. Otherwise, we cannot build, remember. Okay, all your base images that you're using should also support whatever platforms you're trying to build. So it says, those platforms are not no matching platform. Okay, so probably um, we will take a different base. Okay, we will try to take this. Okay, so the base image should also support it. So this is based on, last time, if you remember, we just added Nginx, right? So I'll call it as same thing. The name I'll change. So I'll say Nginx underscore multi-arc latest. Let's see whether it supports or not. Okay, so the Docker file is existing with the same name called Docker file. Okay, I think some architecture is missing.
V7.
Probably ARM v6 or v7. Let's remove them because they may not be supported by Ubuntu. That's the reason it is throwing this error. You can see here it is building for AMD 64 and ARM 64, and it is doing it parallelly. Maybe it's an architecture error again. So let me see. Let me go back to the previous example only. Let's take this Python only. It's not, because we need to see which package supports the platform and all. That is always there. So let me try to build a different image. Okay, so you can see The manifest is also pushed. So let me go back to the Docker Hub and Python multi-arch. You can see you just have only one tag. But if you look at that one tag, you have, both versions, both architectures supported. Okay. So you don't have to separately push AMD 64, ARM 64, then separately create a manifest file and push it. It's not required. So with a single command, you can build, multi-architecture images using Docker Buildx.